In this video, I'm going to go over the derivatives of the inverse trig functions. And we'll start with the inverse of sine and the inverse of cosine. Now, I will derive these. All right, so let's do derivative of inverse sine first. So our function here is sine inverse of x is equal to y. We can always change the way we write an inverse function by swapping the input and the output. So I could rewrite this as sine of y is equal to x. Now I'm going to take the derivative of both sides of this. And in doing so, we'll do the right side first. Derivative of x is just 1. The derivative of sine of y, this is where things get a little bit, just a little bit different than how we may have seen this before. So the derivative, so it's kind of like I have a composition here. I have an outside function, which is sine, and then the inside function, which is y. So the derivative of, so I'm going to be applying the chain rule here. The derivative of the outside function is cosine. Keep the inside function the same. And then I need to take the derivative of y with respect to x. Now, because this is a function, or the variable here is y, I don't know what the derivative of y is with respect to x. So I'm going to write this as dy dx. So I'm applying the chain rule to sine of y, derivative of the outside, so the derivative of the sine function is cosine, keep the inside the same, times the derivative of y, and I can write the derivative of y as dy dx. Now, ultimately, I'm trying to find dy dx, so I can divide by 1 over cosine of y. Now, this seems great, except I want my derivative to be in terms of x, not in terms of y. So I need to do something about this y down here. Now, if we can remember our favorite trig function identity, cosine squared x plus sine squared x is equal to 1, so our Pythagorean identity. If I solve this for cosine, we can say cosine squared of x is equal to 1 minus sine squared of x, and then take the square root of both sides. I'm left with cosine of x is equal to square root of 1 minus sine of x. Okay, and well, I guess I should probably, just to make this, going to change all of these to y's. It doesn't matter. I could use any variable here. But when I substitute into my derivative, dy dx, I'm going to write this as 1 over the square root of 1 minus sine of y. Now I still, or I should say sine squared of y. So I still have this in terms of y, but the reason I do that is because back up here, I had this relationship, sine of y was equal to x. So now that I have a sine squared of y, I can rewrite this as 1 over square root of 1 minus x squared is equal to dy dx. Okay, so, and actually leave some space here. So I could say d dx of sine inverse of x is equal to 1 over the square root of 1 minus x squared. Okay, so that's how we can come up with the derivative of the inverse function for sine. And then let's do a similar process for the inverse of cosine. So again, the inverse of cosine, I can swap those x and y's, and I'm left with, that's not swapping. I could say x is equal to cosine of y. Now when I take the derivative of both sides, derivative of the left side is x, or derivative of x is 1 equal to, now again, this is the chain rule. I have an outside function and an inside function. The derivative of cosine is negative sine. Keep the inside the same, times the derivative of y is dy dx. Solving for dy dx, I'm left with 1 over the negative sine of y. I'm going to write it with the negative out here. Okay, so we're kind of in the same position as we were before. We want to write this derivative not in terms of y. We don't want this y here. So again, we'll use the Pythagorean identity. So cosine squared of y plus sine squared of y is equal to 1. I'm going to solve this for sine. Square root both sides. I'm left with sine of y is equal to the square root of 1 minus cosine squared of y. So I'm going to make that substitution here. So this will be negative 1 over the square root 1 minus cosine squared of y, and that's equal to dy dx. And again, I don't want this, I still have a y in here, but what we see is that I already have a relationship between cosine of y and x. So I can replace that cosine squared of y with x squared. So this comes out to negative 1 over square root 1 minus x squared, and that's equal to d dx of the inverse of cosine. Okay, so those are our two derivatives, one for inverse of sine, one for inverse of cosine. And they're quite similar. The only difference is that the cosine derivative is negative and the sine derivative is positive. Now here I have all 6 of the inverse trig functions, the derivatives of the inverse trig functions listed. And so again, similarly to how the derivatives of the regular trig functions, there's a pattern. We have a pattern here. All the functions that start with a c end up with a negative derivative, and then they kind of pair up, right? So these two go together, these two, and then these two. And then one other thing I'll mention is, and we'll see that in this next example, when we do, let's say, I guess I can just do the inverse sine. So if I want to find d dx of, let's say, sine inverse, now let's say I put a u in there. In other words, this is a function, which if it's x, it's still a function, but let's say it's a more complicated function than just x, like sine inverse of 3x to the 5th. We need to apply the chain rule here. So when I evaluate this, so let's say I have d dx of sine inverse of, I think I said 3x to the 5th. Okay, so if I'm using this formula or this derivative, I'm going to say 1 over 1 minus u squared times the derivative of u. Okay, so this is going to be 1 over the square root 1 minus whatever that argument is for the function, so 3x to the 5th. That all gets squared, and then I need to multiply that by the derivative of that inside function. So that's using the power rule, 5 times 3 is 15, so times 15 x to the 4th. So I could clean that up as 15x to the 4th over the square root of 1 minus, you could square that, 3x to the 5th squared, or you could leave it as is. I guess I'll square it, 9x to the 10th. All right, so that's what you need to remember about these arguments in here. We need to make sure we take the derivatives of those when we're applying these derivative formulas. All right, so a couple examples. This first one, let f of x equal the inverse of tangent of x squared, find f prime. So we're going to use this guy here. So we'll say f prime of x is equal to 1 over 1 plus, now the x here is whatever the argument is. The argument is x squared, so I need to square that, times the derivative of the argument, 2x. So this comes out to 1 over, or I should say 1 times 2x, so that comes out to 2x over 1 plus x to the fourth. Okay, and then one last example in this video. Find an equation of the line tangent to the graph of g of x equals inverse sine of 2x, secant of 2x at 1 comma pi over 3. So we're going to first find the derivative of this g function. Okay, if we look up here, we're now using this. So we'll say 1 over the absolute value of the input. So absolute value of 2x times the square root of the input squared minus 1. And then times, we need to take the derivative of that input. So derivative of 2x is 2. So we're left with 2 over the absolute value of 2x, square root of 2x squared is 4x squared minus 1. And we can cancel that 2. This 2 comes out as a positive 2, and then it cancels. So I'm left with 1 over the absolute value of x times the square root 4x squared minus 1. Okay, so that's g prime of x. Now what we want to do is we need to get the slope at the point 1 comma pi over 3. So we're going to say g prime of 1 is equal to 1 over absolute value of 1 times the square root 4 times 1 squared minus 1. We get 1 over square root of 4 times 1 minus 1, so 3. So square root of 3. So g prime of 1. Okay, so we have our pass-through point, 1 comma pi over 3. We have our slope, 1 over 1/3. So we can put it all together. Y minus y sub 1 equals m x minus x sub 1. And there you have it.